Well, I opened it and all the files are like, you could see the code, but I couldn't figure out what I could do.
Alright, so how are things?
Things are well.
Things are well.
Yeah. Most of them.
So is PA4 falling into place? I mean PA5?
Close.
Close. I'm still getting various questions related to threads and the whole thread handling side of things. Any questions you can ask? So, this client-server model is a good one to be familiar with. And I think I went through this in the afternoon yesterday, but not in the morning. So your assess command that we used in 224, right, is just a link to a file in my home directory called assess, which is a bash script, right? And it does some funny business to look at your arguments and make sure your file name is actually a source file and stuff like that. But ultimately, it runs a Java program called assess, right? So the classes are bundled up in a jar file, but it's really just running a main method from a Java class. And all it does is construct and assess exe object. So what is this doing? Well, it prints out, the stuff that you see and so on and so forth. But ultimately, it makes a connection to a server, right? So it makes a connection to port 1209 on linuxengrcs.com, and it uses the get property method to find out your username, right? And sends that off to the server and starts a dialogue. And assess is really just taking your program, right? So remember, you write a version of your program that's supposed to do something. You link it in with a test bed. You execute it through the assess client. And assess is really just executing it in a controlled environment where it grabs all of the output and sends it to the server. So there's a an execute method, right, that's available, which can be used to run a Unix command, right? And so it uses this to execute your program. It's executing as yourself, so if you delete all the files in your home directory, it's your directory that gets deleted. And then my run returns a string containing the output of that command. So that output is in the string called program out, and then I basically print that to a print writer, right? I send it to the server. And the server is just like the servers we've been playing with, right? It creates a server socket on port 1209 and accepts connections and creates a thread to deal with the connection that comes in, right? Saves some information in that thread and then starts it. And that thread is, well, there's some semi-useful documentation on what the dialogue looks like, right? The client sends a request to the server accepts the connection and starts a thread. The client sends your user ID followed by the source code and then a tag, end of transmission. The client saves that in the file, looks up your UID and a list of authorized UIDs to make sure it's either good or unknown. And then reads the source code until EOT. The client sends a command for what test you want to execute. and then the server basically runs the pristine version of the code that's being assessed, captures that output, compares it to the output that the client sent, does a difference on those, generates a score from that, records the score in the log file, and sends you back a copy of the results. And it's just a bunch of Java code, lots of details, right? But you know, print writers and scanners and sockets and server sockets, and there's really nothing else going on in here. So if you want to, yeah, my commenting's not super great in here, but I have some comments. If you want to see an example of where some of the stuff gets used, right? The stuff is up on Git. It's all public domain. It's a little long, but it's the same stuff we've been doing, right? So one other example, if you saw my talk in the beginning of the year, back in September, when I talked about the research that I do on different computer architectures, and I showed a video of a virtual ecosystem where there were these creatures moving around and they were eating food and attacking each other and mating and so on and so forth. And that's done with a bunch of Java code, right? I had a little virtual computer driving each of these organisms, but they were supposed to be interacting in this common ecosystem, and I set that up in a client-server model, right? So there's the server side, right? And you can use whatever port you want, so you can put a port number in here. I'm just using 1217 and say start and show data. And then over here, I can come into port 1217. And so now it's got a connection, right? It says connected to. And I have a list of commands that I can send to the server, so I can reset the universe, shut down, deposit some energy, create organisms, move creatures left, right, forward, make a query on an individual. That's basically what the simulated systems need to do. So if I want to create some energy, I just use an E command. So there's a little blob of energy, and I can make some more pellets of food, and I can create creatures by using the C command. So now we got some creatures in the environment, and I can take creature 7 and say turn left, and so this creature right over here will turn counterclockwise, and I can say 7 forward, and it moves forward and eats some food and gets a little brighter, and 7 forward, and so on. And so this made it possible to develop the code that was going to drive this without worrying about any of the ecosystem piece, right? Without worrying about where's the food and are these interacting with each other and so on, right? All I needed was a set of code that could basically, if I wanted to move forward, I just made a string with a creature ID followed by a space followed by an F, and I sent that to this port, right, through the socket. And this manages, you know, the fact that it's going to change its coordinates, or there's a piece of food there that it's going to eat, and so on and so forth. And so if you have two organisms facing each other, right, and you try to move forward, that becomes, well, it would become a mating operation if they had enough energy. And then the server will send back information about offspring that were created, and so on and so forth. So client-server setups are sometimes a way to sort of segregate different pieces of your system, right? If you want to be able to interact with something, but you don't want to nail down the specifics of that something in your code, right? You can sort of create a client-server divide, and you say, I'm just going to send this over to you, and you take care of it. And it's another form of modularization, right? But instead of breaking things into a class, put it on a totally different process. It could be on a completely different machine, right? Or I could have, you know, this sitting in my basement, and processes all over the world could be like controlling an ecosystem here. So it's a useful way to sort of partition off your problem. All right, so let's play with URLs. So there's this URL class, right? And we can construct it with what we would put in a web browser typically. So we can say something like URL equals new URL. And we just put in an HTTP string. And I don't know what's going to happen if I do an HTTPS. We'll try that next. Let's just make an opening to clark.edu. And let's make a scanner. I'm going to open a scanner on an input stream reader, which I'm going to construct from the URL using the OpenStream method. So URL OpenStream, let's take a look at the doc. So OpenStream, open a connection to the URL and return an input stream for reading from that connection. So when you go to port 80 and you say get the index.html from this location, it starts sending you back of information. So you can get that information through this input stream, which I'm turning into an input stream reader, which I'm feeding into a scanner. And then we'll just do our usual while loop. Should do it. So let's set up our I/O. Let's set up JavaNet URL and our scanner. And I'll try this without any try-catch blocks to begin with. And it wants a try-catch block. Happy? Oh, I got one more. My scanner. Okay. I'll just go ahead and do that in here too. So you run this, we got a bunch of stuff. So let's put that through more. And what do we got here? Clark College will be open for classes and activities on Thursday, February 22nd, 2018. That's timely. So I guess that's because I'm going to HTTP instead of HTTPS. I'm hitting an old, stale web page maybe, or maybe that was the last emergency message that they had. So policies and procedures, welcome to the Penguin Nation, Clark College in Vancouver, Washington, etc., etc. So this is Clark's web page, right? I don't know what FOP list alt FOP or X means. So let's try ndrcs.com. So moved permanently. Yeah, so this is not going to work very well with HTTPS, but with HTTP it should work fine. Does anybody here use APOD? Nobody looks at APOD?
Oh, I've used that before. Is that the picture of the day?
Yeah. Astronomy picture of the day. So every day you get a cool picture. Right, and these are usually not like paintings or artist renderings. These are actual photographs from space, and they're all like pretty cool. And that's taken from the Hubble telescope. Alright, well anyway, clark.edu is a good choice. Alright, so URL lets you open up a connection and basically grab web pages if you like. In the usual way. Let's try this in Eclipse. Alright, so let's design a page. So let's stick with an absolute layout. Let's put down a scroll pane. And let's make a button. Let's wait for Eclipse. I don't know why first button hangs it up for a little bit, but it does. go button, and I'm looking for JEditor pane. Let's do absolute layout. This is being weird. Okay, so there's our JEditor pane. Okay, so an editor pane is something that I can use to connect the URL class to a visual element. So, so let's write some code. Let me call this pane something reasonable. Editor pane, okay, that's fine. Okay, so let's make a URL. So URL equals new URL, and let's do the astronomy picture of the day. It's going to want to try catch, but we'll put it in later. So editor pane dot set URL or set page. So let me take a look at the documentation. So this is a JEditor pane. So JEditor pane, a text component to edit various kinds of content. So kind of like a text field, right? But it has methods for set page that will take a URL or a string. And set page sets the current URL being displayed. Well, it doesn't tell you much about what it's going to do, but you'll see what it does. So try catch blocks. Alright, so the only code we've added is we constructed a URL with a web page, and then we said editor pane, and we used the set page method to set the URL. And let's just run that. So I'm going to hit the go button and give it a minute, and there's the astronomy picture of the day. And I put it inside a scroll pane, so I have scrollability already, right? And there's a web page. And clicking doesn't do anything, right? Because this is just a window, and in fact I can edit it, right? So it's just reading from that URL, taking the information, reading, interpreting the markup language, and then using that to populate this editor window.
So under the documentation for it, it says that if it's not editable, the hyperlinks will work. How would you go about?
So we can turn off editable. And it's probably in a subclass. Okay, so the JText component has a set editable field. So we can turn that to false. So let's close this out. Alright, so set editable to false, and go ahead and run that, and hit the go button. And so let's click on Discover the Cosmos. Right, and I can't edit this anymore. I give my little, finger pointer when I go over a link, so it understands these are links. But we got to do a little bit more to make it actually respond to these, but it's not a whole lot we have to add. So let's go back to our design, and we're inside our editor pane, and let's add an event handler and hyperlink update. I want a hyperlink listener. Alright, so hyperlink update. So it creates a hyperlink listener, right, and drops me in a section of code. So here's our hyperlink update. And it passes it a hyperlink event called arg0. So take a look at hyperlink event. And it's got get description, get event type, get input event, get source element, get URL. So let's just look at arg0. Bring up our page, click on Discover the Cosmos, and actually I think anytime I point it's giving me information. So what do these things look like? Well, lots of stuff. But somewhere inside here should be a URL. Alright, so when I point to a link, I get the URL that link corresponds to.
So is this basically all a web browser is?
You can make a web browser with this pretty easily. I mean, we're halfway there.
Yeah, but, okay, so I guess my next question would be, when some people say that like certain web browsers are more secure than others, like how would that play into this?
Well, if all you're doing is looking at text pages, that's a pretty secure browser,
Yeah.
right? Unless you have buffer overrun possibilities in your browser. So if you write your code and you use, you know, a scanf with a %s, and you go to a page and the link is, you know, really long, going to overflow your buffer and contains binary code that will overwrite your program memory and get you to start executing some hostile code, right? But barring those kinds of things, right, just looking at web pages, pretty secure. The security issues come in when you start doing things like being able to execute Java code, right, or other scripted languages, or using plugins, right? So I'm going to download a file and automatically display it as a PDF using Acrobat, and you're using some kind of exploit in there. So it's usually not a problem with browsing per se. It's usually that browsers do lots of other things involving, you know, executing code, either that's downloaded or, you know, running local executable code on things that are downloaded, where you start to get into exploits. But a typical browser does so many things now. And the more complex the system is, the more places there are where you can have weaknesses. It's almost inevitable. But you could make a pretty low-ball browser with just a few more lines of Java. So let's make these things clickable. So a hyperlink has a get event type method, and it returns an object of type hyperlink event dot event type, which is going to be activated, entered, or exited. So it's kind of like a mouse over thing, right? When I move to a hyperlink, right, I trigger an event. When I leave that hyperlink, I trigger an event. When I click on a hyperlink, I trigger another kind of event called an activated event. And so I can use my get event type and say if arg0 get event type equals hyperlink event dot activated. And in that case, let's go ahead and print out the URL. I misspell activated. Yes, I did. Okay. So if we run this, we bring up our page. So it should only print that out when I actually click on a link. So I can hover, it doesn't do anything. When I click, it'll actually show me. Yeah, so how do we finish this up so that when we click on the link, it actually goes to that new page? So what does our go button do? Our go button says make a URL from a URL, right? Set the page, make editable false, and that should load that page in. So we can repeat the same thing. Let's put it all in a try-catch block. lost track of my parentheses, but that's okay. Okay, so we'll make a URL, and this time when we're going to open our page, instead of constructing it off of that fixed page, let's construct it from arg0.getURL. What could it possibly not like about that?
Needs to be a string.
I think it needs to be a string. Okay. So we have a hyperlink listener. When we get an event, we'll check to see if it's a click, right? And if it is, we'll print out the URL that refers to. We'll construct a new URL object, use that to set the page on the editor pane, and then we'll set it editable to be false, which I don't think we have to do every time. And that should load in the new page. So there's our original. And if we come down to discover the cosmos, there's the index. And we can come down to, I saw a deep field somewhere. This kind of hangs up sometimes too. Let's try it again. Stop. Okay, we'll discover the cosmos, and let's do dark nebula. Alright, so I think it's trying to load this page, and this is a long page. So let me do it different. This is not a very good web browser. Let's go down to famous 3 stars. Alright, so there's another picture. And Martin Moody. Okay, so that's a mail too. So, and we don't understand how to mail things. Belt of Orion. Or not. There we go. So some of these pages are working better than others. But anyway, now we're on a Wikipedia page. Right, so pretty rudimentary, but like this is the essential mechanics of a web browser. So the only real pieces here are the URL class, right, which lets us construct a page, and then using a editor pane to use set page to load the contents from that URL into the object, and then responding to hyperlink events, which again I did just by the usual adding an event handler, and there's one hyperlink update. So this is almost like, you know, the ultimate example of why we're doing classes and objects in the first place, right? This is a huge amount of machinery that's bundled inside, you know, 2 or 3 method calls, and we make a URL with a URL constructor, and we can say, you know, get the input stream, or we can pop it onto an editor pane, And by putting that inside a scroll panel, we've got scrollability, right? And it's really just kind of like building on top of all these mechanisms without having to actually deal with them or know how they work or care how they work. So questions about this? So how do you add a history feature to your browser? How do you add a back button? Okay, what should we store them in?
Stack.
Store them in a stack. Perfect. All right, and the last thing that you put in the storage will be the first thing that you pop off. So when you say back, go back to the previous page. When you go back again, it goes back to the page before that. If you go back and you get a stack underflow, there's no page before that because you're on the first page. So, you know, gray out the back button now. All right. So it's all the stuff that we've been doing, right? It all like, it's not just academic. Color in the human brain, cool.
Tried to make a program one time that would just grab the image off of APOD and set it as my wallpaper every day.
Oh, cool.
But I didn't know how to do it at the time, so
Now
I
you
might
do.
try that again.
Yeah, totally. Yeah, and if you, I don't know if I can get back to my original. Yeah, I can. If you actually look at the HTML that comes from here, so come on, Chrome. Right, if you look at the raw HTML, so Control U brings you to the HTML, right? You can come through here and figure out which one of these refers to the image, unless it's buried behind a PHP or something. And there's usually a standard name that's being used for today's, right? So you could pull that out, or you can parse through this and try to grab it like that. But yeah, I'm pretty sure you could do something in Java using just what we've done already. All right, so Open Lab tomorrow. I'm debating whether to do an Open Lab on Friday, but I only want to do it if it's going to like be helpful to people, as opposed to just a Friday off. So let's see what happens Thursday.
Can we have the next Friday off?
How about the Friday after that? We can like do spring thing or something on next Friday. All right, if I decide to do Open Lab Friday, I'll post something on Canvas on Thursday. Otherwise, we'll play around with some jar files and look at how we can connect other packages into our Java project.
I found some programs that other people had made